So one nice thing that we can do with percents is talk about interest. So if you have a savings account or maybe the right kind of checking account, your money sitting in the bank actually makes you money. The bank pays you what's called interest. If you have my Math Connections class, we've talked about this 1,000 times. If you don't, you're probably going to have it next year. Just something to kind of be aware of. So my savings and checking accounts both pay interest. The way my checking account is structured, the more money I have in it, the higher interest rate they pay, which is kind of an incentive to keep money in it. So basically, the bank pays you money to have money in their bank. Okay, what they do with that money is they loan it out to other people, and that whole thing is a whole different conversation. But there is a formula that is used on how to calculate how much money the bank pays you. It's called the simple interest formula. Now, simple doesn't mean it's super easy, although it's not real complicated once you kind of work with it. There's different kinds of interest. This one is called simple. There's compound. There's different types of compounded interest, but that's neither here nor there. So simple is what we're shooting for. There are four different variables here, I, P, R, and T. I is the interest that the bank pays you, the money you make, literally for doing nothing. Okay, you don't have to work for this. You just leave your money alone and the bank pays you interest. The way that interest is calculated is they take the principal, that's the money you put in the bank, they multiply that by the interest rate as a decimal, and then by the amount of time you leave the money in the bank. That is always in years. Now, for us, I'm going to keep it as whole number years, 3 years, 5 years, 10 years, whatever. My Math Connections class has done things like 18 months. And then we had to do a little bit of a conversion work there to get that lined up to a number of years. But I'm not doing that on you guys. It's just straight years. So we're going to do two different things with this. I'm going to give you the principal, the rate, and the time, and we're going to calculate the interest. And then the other one is I'm going to give you the interest, the principal, and the rate, and we're going to have to calculate the time. Okay? Very similar calculations using the exact same formula. So I've kind of split this up, and your homework's kind of split up in sections too. The first 4 or 5 questions, you're calculating the interest. The last 4 or 5 questions, you're calculating the time. So grab your calculator. You'll definitely want to use a calculator on these. So our interest that we're going to calculate is the principal times the rate times the time. So your dollar amount that you're investing is your principal. Your rate, change that to a decimal. That is your R, and your time is 5 on this one. So I'm going to plug those 3 numbers in here. Principal is 1800, your rate is 0.03, and my time is just 5. That is just 3 numbers multiplied together, and you're done. Okay, so 1800 times 0.03 times 5, that is $270. So if you put this money in the bank and leave it alone, you don't touch it, you don't add anything to it, you don't take anything out of it, that money in 5 years is going to earn you $270. Now, that's not a whole lot of money, okay? Especially if you need your $1,800 to do things. There's some other things to kind of consider with this. If you make like weekly or maybe bi-weekly deposits, that's going to build this money up a lot faster. That is not a simple interest calculation, okay? So another one, same thing. We're going to find our principals, our dollar amount. Our rate is 0.07, and our time is 3 years. $31.50. So you're not going to make $1 million doing this by any means, okay? But it is kind of nice to know your money's not just sitting there getting dusty. It's actually working for you a little bit. We'll skip this last one. It's the same thing. So here's the other kind of problem that I have. So we're going to take $1,000 and we're going to invest it. Okay. And at the end of our term, we want to have $2,000 in the bank. So what we're doing here, I'm going to invest $1,000 at 6% interest, and I don't know for how long. That's what we're trying to figure out. So at the end of the time this money's in the bank, I want $2,000. But here's the catch. That includes the original $1,000. Okay, so I had $2,000. I put $1,000 in the bank, and so many years later, I want $2,000 in the bank. That includes the original $1,000. So I only made $1,000 interest. Okay, so Combined, these two guys total $2,000, right? The $1,000 that we invested and the $1,000 interest that we're earning. So what I'm going to do, I'm going to solve this equation. Okay, I'm going to multiply these guys together to get one number instead of two. So 1,000 times 6%, that is 60. And then you just divide it out. Okay, that is a very straightforward equation that we were solving way back in August. So if I take my $1,000 and divide it by 60, I like these problems. That's going to take almost 17 years. Okay. Is it worth it? I don't know. But that's kind of how it works. You put money in there, you leave it alone. Okay. The other kind of interest is called compound interest. We're not going to get into that. It is actually something that we did way, way, way earlier in the year. I gave you all the information, you plugged it in. Compound interest, that's where you make money. Okay, same idea. We've got $500. That's our principal. Our interest rate is 0.045, and the time's what we're trying to figure out. At the end of this time, we want to have double that. So I want $500 in the bank, and I want $500 interest on top of it. So a total of 1,000. So when I multiply the 500 and the 4.5%, that's 22.5. I'm going to divide that out of my 500. That is going to, sorry, they're just making me laugh. That's going to take a little over 22 years. Okay. It's just kind of another way to use the formula. Are you going to leave $500 in the bank setting a loan all by itself for 22 years? Probably not, but you could.